In this video for Positive Maths, we're going to learn about problem solving when angles of elevation and depression are involved. So trigonometry is an incredibly useful tool for solving real-world problems, such as finding the heights of things, finding distances between things, and so on. So we will see a lot of examples of these in exam questions. To solve problems, we will again utilize the trigonometric ratios and Pythagoras' theorem. We will also encounter two new ideas quite regularly. These are the angle of elevation and the angle of depression. The angle of elevation is defined as the angle you must look up to see an object. So for example, from here we have our angle of elevation. That's the angle that we're looking up to a certain object. The angle of depression then is the angle that we're looking down to an object. And this is from the horizontal line. Let's look at some examples of these types of questions. So a ladder makes an angle of 62 degrees with the ground. The base of the ladder is 1.4 meters from the wall. Find the length of the ladder. So let's just underline the important pieces of information. So it makes an angle of 62 degrees with the ground. The base of the ladder is 1.4 meters from the wall. And we want to find the length of the ladder. Our first task is to draw a suitable diagram to solve this problem. So, first of all, we have our wall and the ground. Then we're going to draw in our ladder. Now we're going to mark in the important information that we underlined in the question beforehand. So we have 62 degrees. The ladder is making an angle of 62 degrees. The base of the ladder is 1.4 meters from the wall. And we're going to use this information to find the length of the ladder. So the first thing we need to do is to label the information that we're given. So we have our angle of 62 degrees. This is creating a right angle with the wall. So we want to label, but therefore 1.4 meters is the adjacent side. So I'm just going to mark it with a small a. And the length of the ladder is actually the hypotenuse of the right angle triangle. So we want to really recall at this stage, if we have an angle, we use cosine to find one of the missing sides, in this case, because we have the adjacent side and we're looking for the hypotenuse. So we're going to write down that the cosine of 62 degrees is equal to adjacent over hypotenuse, which in this case is 1.4 over h. So the cosine of 62 degrees multiplied by h is equal to 1.4. So therefore h is equal to 1.4 divided by the cosine of 62. So we go to our calculator, put in cosine 62. So now it's going to be 1.4 over 0.4695. So now we have 1.4 divided by 0.4695. So our answer is going to be 2.9819. So if we're asked to give our answer to the nearest meter, then our answer is going to be h is equal to 3 meters. So the length of the ladder is equal to 3 meters. Let's look at another example. Thomas stands 4.5 meters from the base of a tree. He uses a clinometer and measures the angle of elevation to the top of the tree to be 48 degrees, and the angle of depression to the base of the tree to be 22 degrees. Find how tall Thomas is and find the total height of the tree. So again, we're going to go through and highlight key bits of information. So he's 4.5 meters from the base of the tree. He uses a clinometer and measures the angle of elevation to the top of the tree to be 48 degrees. Then he measures the angle of depression, 22 degrees. We need to find how tall Thomas is. and find the total height of the tree. So again, the first thing we're going to need to do is to draw a diagram to represent this information. So the first thing I'm going to draw a vertical line which is going to represent the height of the tree. Now I'm going to mark 4.5 meters, which is the distance that Thomas is standing from the tree. I'm going to mark in the height of Thomas, and now the angles of elevation and depression. So our angle of elevation is 48 degrees, and the angle of depression is 22 degrees. So now we can see that we have two main right angle triangles. The bigger one that has one of the angles is 48 degrees, and the smaller one where one of the angles is 22 degrees. So we want to notice we need to find the height of Thomas, and we need to find the total height of the tree. So first of all, we're going to realize that the height of Thomas is this part here. To find the total height of the tree, we then need to find this part here. So I'm going to mark this with A, mark this with B. So Thomas's height is A, and the total height of the tree is going to be A plus B. So the first thing we're going to do is we're going to find A. So to do this, we're using this small triangle. So if I draw a quick sketch, we have a right angle triangle, we have 22 degrees. We have this distance at the top, 4.5 meters, and we're looking for the side A. So we notice that we have the opposite side of the angle, we have the adjacent side. So we're going to use the tan to find A. So the tan of 22 degrees is equal to the opposite over the adjacent. So that's A over 4.5. So therefore the tan of 22 degrees multiplied by 4.5 will give us A. So again, we'll go to our calculator, put in tan 22, we get 0.404 multiplied by 4.5 will give us A. So 0.404 multiplied by 4.5 is going to give us 1.8181 for A. And we're not going to round it until the end. Okay, so Thomas's height we will, just for our answer, we're going to put 1.8 meters. So now we're going to find the height B. Again, I'm just going to draw a rough sketch of the triangle. So we're using the bigger right angle triangle now. We've 48 degrees. We're looking for B, and again we have this distance here, 4.5 meters. So if I label the sides that I have in relation to the angle, I'm looking for the opposite and I have the adjacent. So again, I'm going to use tan because tan involves the opposite and the adjacent. So the tan of 48 is equal to B over 4.5. So the tan of 48 multiplied by 4.5 is going to give us B. So again, we go to our calculator. Tan of 48 degrees gives us 1.1106. Multiplied by 4.5 is going to give us B. So we get 4.9978 for B. So again, we're going to round this to just one decimal place. So because it's 4.99, it's just going to be 5 meters for B. So for the second part, the total height of the tree, we have to add 1.8 plus 5, so it's going to be 6.8 meters. For more information, visit PositiveMaths.ie, email us at info@PositiveMaths.ie, and follow us on Facebook and Twitter. Thanks for watching.